Welcome to our session on business research methods. Today, we'll be exploring a core aspect of rigorous business research, the process of theory building. Theory building is very helpful for conducting research that is sound and insightful. Such research can help explain complex business phenomena and allow us to make more informed predictions, supporting strategic decisions. By the end of this comprehensive session, our goal is for each of you to have a strong and clear understanding of several fundamental areas of business research and theory. We'll begin by precisely defining what a theory is within the context of scientific inquiry, and then we'll thoroughly discuss the main goals theories aim to achieve in explaining the world around us. You'll also gain an in-depth understanding of the essential building blocks from which theories are meticulously constructed, dissecting key components such as concepts, propositions, empirical variables, and testable hypotheses. We'll also dedicate significant time to discussing the various systematic processes and approaches researchers use to thoughtfully develop, refine, and iterate robust theories over time. Finally, we'll conclude our session with an essential overview of the scientific method itself, recognizing it as the overarching, rigorous framework that underpins this entire endeavor of theory building and empirical validation, and ensures our research is systematic and objective. Theories are not just for academic study. We apply theoretical thinking daily. Consider flipping a light switch and the light doesn't come on. You would naturally start to form small theories to understand why. Perhaps the bulb is out, or there's a power issue, or a circuit breaker has tripped. This process of using logic and experience to explain things is how theory works in practice. A more formal illustration is attribution theory, which explores how we assign causes to events and behaviors. Let's now define what a theory means within scientific and business research. Essentially, a theory is a structured, logical explanation for specific events or phenomena. It goes beyond merely describing what happened to carefully explain the connections and influences between different factors. A strong theory can also help us predict how these elements might behave under certain conditions. Theories have two main goals in advancing our knowledge. First, they help us understand by offering clear explanations for relationships among concepts. Second, they support prediction, allowing us to anticipate the outcomes of actions or events based on these theoretical relationships, which aids in decision-making. At the core of any solid theory are its basic building blocks, known as concepts or constructs. A concept is a general, abstract idea that groups similar objects, attributes, events, or processes, and we give it a name to help us identify and communicate. You can think of these as the fundamental nouns in our research language, helping us organize how we see reality. For example, leadership is a broad idea encompassing many behaviors and qualities related to guiding others. In business, we use many important concepts daily, such as employee morale, gross domestic product, assets, customer satisfaction, and market share. These carefully defined concepts are crucial because they help us organize complex observations, simplify reality, and communicate intricate ideas clearly among researchers and practitioners. To better illustrate how theoretical building blocks connect, let's explore social network theory. This theory was developed to explain and predict patterns of relationships, or links, and the resulting structures within social networks. These networks can involve individuals, groups, or organizations. Social network theory uses specific constructs to define its elements. For example, nodes represent individual actors, and ties or edges denote the connections between them. The theory also presents propositions, which are formal statements about the expected logical connections and dynamics within the network. These propositions explain how relational ties are formed, maintained, or dissolved, and the benefits they yield, such as social capital, based on the network structure. It's helpful to note that concepts vary in their tangibility, ranging from concrete to abstract. The ladder of abstraction is a valuable tool that helps us organize and understand the spectrum. At the top of this ladder is the abstract level, where ideas exist as qualities or general notions, separate from physical objects. Examples include broad concepts like wealth or intelligence. At the bottom of the ladder is the empirical level, representing knowledge that can be directly observed or measured. This involves tangible data points, such as a specific bank balance or a test score. Many important concepts in business research, like brand loyalty or organizational culture, are latent constructs. These cannot be directly observed, but are estimated indirectly by carefully measuring related indicators. For instance, brand loyalty might be inferred from repeat purchases or a customer's willingness to recommend. This diagram clearly illustrates how the ladder of abstraction works, moving from broad concepts to specific measurable indicators. At the very top, the most abstract level, we might consider a general idea, such as corporate success. As we move down the ladder, we become more concrete, refining corporate success into financial performance. Further down, financial performance can be broken down into clearer concepts, such as profitability and revenue. Finally, at the base of the ladder, we reach the empirical level, where these concepts become precise, observable variables. For example, quarterly net income in dollars serves as a concrete measure of profitability. This careful process of moving from the abstract to the empirical is essential for conducting meaningful research. It helps us connect theoretical ideas with what we can observe in reality. It is important to remember a key truth about all concepts we use in research. Each one is an abstraction of reality. The world around us is incredibly complex, with countless variables and details that are impossible to fully grasp at once. To systematically study and understand this complexity, we must intentionally simplify it. This simplification means focusing on specific, manageable concepts while setting aside many other intricate details. For instance, when we use the concept of a customer in business research, we are using an abstraction. This concept distills a complex human being into a role primarily defined by their relationship with our business. This process of simplification through abstraction is not a weakness, it is essential. It makes scientific inquiry and systematic research feasible, allowing us to study specific relationships and phenomena. Once we have defined our core research concepts, the next step in theory building is to establish relationships between them using propositions. A proposition is a statement that describes the logical connection or expected association between two or more abstract concepts, purely at a theoretical level. For example, treating employees better will make them more loyal suggests a theoretical relationship between employee treatment and employee loyalty. To test this idea in the real world, we must formulate a hypothesis. A hypothesis is a formal, unproven proposition that has been carefully refined to be empirically testable. This means it can be examined through collecting and analyzing observable data. Taking our example, the proposition, treating employees better will make them more loyal, can become a testable hypothesis. Giving employees one Friday off each month will result in lower employee turnover. This transformation moves from general concepts to specific, measurable interventions and outcomes, connecting theory with empirical investigation. Empirical testing is the crucial point where our theories and hypotheses meet the observable world. It is a systematic process of collecting and analyzing data to see if a hypothesis is supported by real-world evidence. To do this effectively, we transform our abstract concepts into measurable entities called variables. A variable is how we empirically assess a concept. It is anything that can take on different numerical values or categories when measured. For example, age as a concept becomes a quantifiable variable when measured as number of years since birth. The key process of precisely defining how a concept will be measured in a study is called operationalizing. This involves carefully identifying the exact measurement scales or procedures to assess the variables. For instance, to operationalize customer satisfaction, a researcher might use a survey scale where respondents rate their satisfaction from 1 to 5. This precise definition is crucial for the validity and reliability of our research. This slide helps us understand the important relationship between propositions and hypotheses in research. Propositions can be seen as residing in the abstract realm of theory, describing broad relationships we believe to be true between concepts. These propositions are foundational for theoretical frameworks, showing how elements might interact. Hypotheses, on the other hand, are their direct counterparts in the tangible, observable world. A hypothesis is a carefully constructed bridge that allows us to move from an abstract theoretical idea to a specific statement that can be tested with observable data. Without this bridge, our theories would remain as speculation, lacking the means for validation or practical application. To bring together our understanding of concepts, propositions, and hypotheses, let's look at a theory explaining voluntary job turnover. This model clearly shows several key concepts for understanding why employees might leave their jobs. These include job performance, how well an employee does their duties, and job satisfaction, their contentment with work. The arrows in the model represent propositions, which are theoretical statements about the expected relationships between these concepts. For example, an arrow from job satisfaction to thoughts of quitting suggests that lower job satisfaction may lead to more thoughts of leaving. Each of these theoretical propositions can then be carefully turned into a precise, empirically testable hypothesis. Using our example, the proposition about job satisfaction and thoughts of quitting could become, employees with lower job satisfaction ratings on a survey will report a higher likelihood of thinking about quitting their job. Theories, which form the basis of scientific understanding, are developed through two distinct yet complementary types of logical reasoning. The first is deductive reasoning, often called a top-down approach. This is a logical process where a specific conclusion is drawn from a general premise or an existing theory. It starts with a broad theoretical statement and then predicts or explains specific phenomena, leading to testable hypotheses. The second mode is inductive reasoning, a bottom-up approach. This involves establishing a general proposition or new theory based on careful observation and analysis of particular facts. Here, researchers begin with detailed observations, look for patterns, and then generalize these patterns to form broader principles. Both deductive and inductive reasoning are essential parts of the scientific process. They often work together in a cycle, with inductive reasoning leading to new theories that are then deductively tested, continually advancing our knowledge. Ultimately, all the elements we have discussed, concepts, propositions, hypotheses, variables, and reasoning modes, come together within the guiding framework of the scientific method. The scientific method is a systematic set of procedures designed to establish theoretical statements, analyze empirical evidence, and predict events. Its importance lies in ensuring our research is logical, transparent, repeatable, and objective, thus increasing its credibility. The process usually begins by assessing existing knowledge and prior research, identifying areas for further study. From this understanding, researchers carefully formulate concepts and develop propositions about their relationships. These abstract propositions are then refined into specific, empirically testable hypotheses. The next stage involves designing the research study, carefully choosing methods and data collection techniques to test these hypotheses. After design, we gather the necessary empirical data through various means, like surveys or experiments. Once collected, the data is thoroughly analyzed to find patterns and determine if the evidence supports or refutes our hypotheses. Finally, based on this analysis, researchers propose explanations, draw conclusions, and identify new questions, continuing the cycle of scientific inquiry.